Talk about the types of platforms. Here we're going to discuss fixed wing, rotary wing, multi-rotors, lighter than air, and tethered. We're going to begin with fixed wing platforms. And fixed wing platforms are very similar to an airplane type of configuration. There's a multitude of different airframe and power plant options available for fixed wings. They can take electric propulsion, they can take combustion propulsion, and probably a couple of others as well. They're very, very flexible. They're probably the simplest and most efficient aerodynamic structure of all the UAV platforms that we're going to be talking about today. They have great endurance and cruise speed. They're very stable. You can have lots of different configurations, both in the airframe, payload, propulsion. They are really good in some configurations for being able to lift high weight capacities. They have good lift to weight ratios. So if you have some payloads that could take advantage of this, these could be a platform to consider. One of the drawbacks that they have is they do have launch and recovery factors that need to be considered. Depending on the scale, the type of platform and configuration that you have, you may not be able to recover the platform in the same location from which you launched it. Some launch simply by hand deploying them. You can just throw them into the air and start flying them. Some require catapults. Some of them require runways. For recovering or landing them, there's several considerations. You may need a significant amount of space, and if you're in a heavily forested area, that may not be available to you. There are other containment systems that can be used, nets and some other systems that can be used. And also, for them to loiter in rugged or enclosed terrain, they have to orbit. They have to go in a circle. They don't have the ability to stay stationary. Of all the platforms, these have probably the lowest maintenance requirement of all the ones that we're going to discuss today. Next, let's talk about the rotary wing. And this is very similar to a helicopter. But rotary wings are very complex mechanical and aerodynamic platforms. There's a lot going on, and there's a lot of vibration that occurs with these types of platforms. Because of their aerodynamic characteristics, they have limited endurance and cruise speed when you compare them to a fixed wing platform, for example. But they are extremely stable. You can do a lot of different payload configurations with the rotary wing. They're very agile and maneuverable. And they also have a vertical takeoff and landing capability, or what's often referred to as VTOL. They can loiter and operate in rugged terrain or even enclosed terrain because they don't have to orbit. They can maintain a stationary fixed position, move very, very slowly, get very, very close to objects for inspections, as an example. And they also have multiple power plant options. You can get one that's purely electric. You can get one that has gas or some sort of other combustion engine. There's even turbines that are used for rotary wings. And there's even some hybrids that are coming online, which is a combination of any two of the ones that we just mentioned. Because of their complexity, they do have a high maintenance and inspection vigilance that needs to be maintained to ensure everything is checked and flight operational at all times. Next, let's talk about multirotors. Multirotors, I would say, are the most complex electrical airframes. Everything that requires coordinated and stable flight requires some sort of electrical impulse to control each of the motors to maintain a hover, stable flight, directional control, and they're constantly inputting all the signals and inputs from the operator, all the GPS information that they're getting from the satellites, and all the other information that they have to process. They are extremely stable, very low vibration, much lower than that of a rotary wing. They have multiple payload configurations. They're very agile and maneuverable. They also do have the vertical takeoff and landing capability, and they can loiter and operate in very rugged or enclosed terrain, and even indoors. Their limitation right now is primarily their only propulsion system is electricity. So you're really constrained by how much electricity you can carry in the form of batteries, which are typically very heavy. So you can get anywhere from maybe 20 to 40 or even 60 minutes on the outside range with a multi-rotor. But the trade-off is going to be your payload. The more batteries you have to carry, the less your payload capability. Rotary wings, for example, there are some rotary wing platforms that can carry 50 pounds. Multi-rotor, you could probably build one, but they're really not made for that capability, primarily with the limitation of their power plants right now. And they also have a high maintenance and inspection vigilance because of all of the software and firmware that's required for those to be able to fly in a coordinated fashion. Next, let's talk about lighter than air platforms. These are probably among the most simple airframes of all the platforms that we're going to be discussing today. And they have very, very few components or moving parts associated with them. They have high and even extreme endurance, but really don't have very good cruise speed or agility. And they are going to be more susceptible to weather conditions, whereas a fixed wing, rotary wing, or even a multi-rotor can compensate for winds by flying against them. And most lighter than air really don't have too much thrust available for them to counteract any wind disruptions. They do have multiple payload capabilities. They are extremely stable in good weather conditions. They do have takeoff or launch and recovery and limitations, in that typically they have tethers for some of the more moderate and larger scale ones. And they have moderate maintenance and inspection depending on the type of gas that you're using to make them lighter than air. Sometimes you'll see small scale ones being used indoors at certain sporting events, which is great because they can hold a small camera and have lots of control and don't put off a lot of noise. And finally, we're going to discuss tethered platforms. Not really used or get too much attention in the mainstream, but they are a very viable solution. A tether is just usually a multi-rotor or a lighter than air platform that has a connection to the ground, which will provide power, communications, and any sensor or payload information back and forth. So this gives you a lot of flexibility. Very, very high endurance, but you are going to have a trade-off in that you're going to be limited to your altitude and range based on the tether. There are some larger tethers that can pull a very heavy cable and go up to about 800 or 1,000 feet and have a very, very sophisticated payload on them. And they are also very portable. You can have a tether out of the back of a pickup or some other mobile platform that may give you a little bit more mobility. And they can loiter, again, very, very long periods of time. They could stay up indefinitely, but you probably would want to bring them down for periodic maintenance, maybe once or twice in a 24-hour period. If it's a multi-rotor, just to check all the motors and the propellers and make sure that there aren't any vibration concerns that may become apparent. And these will be on the higher end of maintenance and inspection considerations. So now let's look at some of the different considerations. We've talked about the different types, 5 primary. There are probably even some others that we could discuss, but these are the ones that we're focusing in on that are going to be the most predominant. And that's fixed wing, which are like airplanes, rotary wings, which are like helicopters, multi-rotors, which again, those can be 4-way, 6-way, 8-way, 10 ways, and even up to 12 waves, motors on them. And then propulsion. We have electric, gas, turbines, and hybrids are the primary propulsion systems. And there's multitudes of main factors to consider, but the 4 primary ones that people hone in on are listed here. And those are endurance, which is how long they can stay in the air, their agility, how well they can maneuver, their payload and sensors, what can they carry, their weights, the different types of sensors they may be able to carry, and then what kind of weather conditions can they operate in. And then when you're looking at these, it's important to have a comprehensive analytical framework that drives your needs assessment to determine which platform is best for you. And as we move forward, we'll talk about what that might look like.